morning. And today we have two lectures. And the first one, it will be about R, and then the second one, it will be about probability. Usually from experience, the second lecture about R, it might take a little bit longer. It can be 2 lectures, it can be 3. So let's see how far we can get. So the general purpose of this introduction to R is that I know all of you know R already according to the survey we have. But maybe there's something you still don't know, not sure. So there's some tips and tricks when you are programming in R. So I'm not sure that, all of you know that, and I'm also not expert. I just tell you what I know already, okay? So, and then this purpose is to bring everyone onto the same page. From today on, I will introduce also something called a Bayes warm-up. Basically, I will ask you to think about what we have talked about, discussed from the last session. But from today, this one doesn't make too much sense because last week it was our first lecture. The first lecture, it was only about introduction, and we just talked about how you will get graded, right? But the general purpose of the Bayes warm-up is basically if you know the concepts of prior and posterior, you actually know that your posterior today will be your prior tomorrow, right? So then the knowledge will get updated from each time. So for example, if we resume our lecture on the 22nd of April, and then I will ask you, well, what we have discussed today, right? And then you will think about, well, okay, we discussed R probably, we discussed some programming tricks and tips, and we discussed something like probability if we cover that topic. Good. And I guess you do not have questions at this moment. I guess you do not. So let me just get started. I will talk about some basics of the R programming language to bring everyone onto the same page, as I said. So R, as you know, it is a programming language for statistical computing. And R has its own interface. So the idea is that when you install R onto your computer, either it's Windows or Mac, doesn't matter, you can open R on its own itself. It has an interface, but it doesn't look nice. And people usually don't use that very often. So what people use is a platform, or actually it's an IDE, integrated development environment for R. It is called RStudio. So it is a more sophisticated R-friendly editor with some helpful syntax highlights. I guess most of you have already used that already, as I remembered from the survey. So this is quite trivial. So the idea of the RStudio, if you open that tab, here there is a division of 4 windows, sub-windows. This one, the top left corner, this is the scripts editor. It is basically a text editor. You write down your code, your script, and save it as an .r file, and you can use it, reuse it later on. Then the bottom corner, bottom left corner, it is the console. This is like the terminal. You can type some simple commands, for example, 1 + 1 = 2. You can type it here. Then the next window is the environment and also the command history. So what you can observe here is that this window, there are 2 tabs. One is the environment, the other one is the history. Environment is like the working memory. For example, if you type A = 5, then here A will appear here. This is the working memory. So if you know some other programming languages, this is also called a workspace, your current variables that are available so that you can use. The variable is a generic term, not only variables you declare, and it also includes functions you define here. I will talk about the functions later. Another tab is called history. So basically your command history. You can go back to see what you have typed in your command history. The last one, the right bottom corner, it is there are multiple tabs, as you can see here. For example, files, plots, packages, help, and viewer. The most common one, most useful one is actually the files, because if you open an RStudio, if you click this files tab, you will see your files, basically your data, your scripts, your plots saved as external file, for example, like a PDF here, all those are files, right? And here, this is the actual plots tab. If you plot a scatter, for example, if you plot a regression line, for example, all those plots will appear here, also here. And then another one is called packages. We will also talk about the idea of package. Basically, if the basic art is not very helpful to help you solve some problems, you might want to go to the internet and download some other external packages. And here, this is the list of the currently available packages. And help is the documents. If at some point you're unsure about how to use a function, and you will go to the help document to see the help document to basically tell you how to use that command, how to use that function. So viewer is most of the case not very useful, and I rarely use that, honestly. So the most important one here, the files. You see your file structure and the plots to make some plots. Packages, usually you also don't need it because you can use commands to control your packages. Help is important because this is the place to see the documents, okay? Help documents. Perfect. And our very first R command, if you have another screen, if you don't mind, you can also try it on your own local R, but maybe you can just watch, and later when you are reviewing the video, you can just type on your own, okay? The R version command is basically tell us what the current version of R is. So as you can see here, I'm on the Windows machine, and then the system here, Windows, and then the version, this is the old output. So here I did this 2018, and then there are some other information. The most important ones here, usually most of the case, it is the R version. So in this case, it is 3.5.1. So why this R version sometimes might matter, it is because whenever you have some problems, errors, bugs, when you are using R, you might want to Google, right? And then some of the errors or problems are version specific. So there might be a version here, for example, but when the R is updated to, for instance, currently 3.6.1, then the error or the problem is gone. So this is quite important. It is really recommended to also enclose your R version, this number, whenever you want to ask a question about R on some of the forums, for example, Stack Exchange, for instance. And so the console, if you remember, the console is the bottom left corner. That's console. Here, the console. You can basically type some easy commands, right? So what you can do is basically use R as a calculator. You can say plus 3 plus 2, for instance, and 3 minus 2, and then you can do multiplication. You can also do division. It's basically as you type in a regular calculator. And here you can also do exponents. So here this means 3 to the power of 2, and then this one, same idea. This is reverse, 2 to the power of 3. Okay. There are two very important constants in R. So one is pi, and then the other one is the base of the natural logarithm. Okay, also the exponents. So here it actually means e to the power of 1. So then that's the e itself. If we say exp2 instead, then that means e to the power of 2. So that's the square of 2.71 or 72. There are a few special values in R. this is infinity, and you can do 1 plus infinity, but what you will get is actually again another infinity. There is a special variable which is called the machine precision, and this is the smallest precision the machine or the program could achieve. So usually, if I recall correctly, most of the programming languages, the machine precision is around e to the power of -16 or maybe 17 here. And this is a very small, very tiny, excuse me, very small and very tiny positive value. So if we say, is 0 larger than that one? No, because this one is larger than 0. This is positive, okay? These are a few special variables. There are 2 others. One is called null. It's basically empty, nothing. And here NA is not available, means missing value. For example, if we run experiments, if we ask the participants to press a button whenever they see some stimulus, and we give them, for example, 3 seconds window to make the response, and if they sometimes are too slow, and then they miss the response. So what we can do in our data log file is to say, is to code it as a NA. Okay, it is very common and helpful if we encode missing values as NA. This is helpful not only for us that we know this is a missing value, it's also very helpful for our later analysis, because R is quite powerful in detecting and neglecting the missing values whenever you do some subsequent analysis. The next very quick recap about R is basically we use the numbers here, right? 3 plus 2 directly. We manipulate the numbers, but this is not always what we do in our daily life, in our daily data analysis pipeline. We work not only with the direct numbers directly, we also work with variables. So here, for example, we could assign this number 3 to a variable called x, and then we can assign another number 2 to a variable called y. So here the equal sign always means you want to assign something from the left, the right, sorry. You always want to assign something at the right-hand side of the equal sign to the left-hand side of the equal sign, okay? And whenever we have these 2 ready, so when we have these 2 ready, we have x and y, these 2 variables in the R environments, the workspace, as you remember, and then we could manipulate the variables instead of the numbers. So when we have done this, what we can do is to say, well, can we do x plus y? Yes, of course. Can we do x multiply with y? Yes, we can also do that. A short note or short warning that I can tell you is that R is case sensitive. So small x and capital X, they are different variable names. They're different. And the next one is about we want to combine the values. So we do not want to work with only 2 or 3. We want to combine them as a vector, for example. I will tell you what a vector is if you don't know. It's basically a list of numbers or a list of letters, characters. So how to combine them? It is to use this C command. If you say C here in the parentheses, and then separating those elements by comma, then you can combine 1, 3, -2 into a sequence of numbers. Those don't have to be numbers. They can also be letters, A, B, with the double quotes. So if you use the C again to combine them, this will be a list of letters. So when we have the list of numbers, for example, we can then do many things. For instance, we can calculate what is the value when we sum them up, for instance. We can use a function called sum to have the overall summary. We could also calculate the average, the mean. So then in this case, we can use this function only just called mean to calculate it. We could also calculate the variance. We could calculate also the standard deviation. Here, these two commands are also quite useful, very handy in your exploratory data analysis. You want to know the minimum of a sequence. You want to know the maximum of a sequence. Let me give you one example. We could, for instance, record the reaction time for 100 trials from one person. And then we want to see what is the smallest reaction time by using this. We could also see what is the largest reaction time by using this command max. Good. And then the same idea applies here, right? We do not directly work with those vectors. We work with variables. So what we do is we assign, again, the idea from the right-hand side of the equal sign to the left-hand side of the equal sign. So we assign this vector to x, we assign another vector to y. And then we have two lists of numbers. We can also do calculate the correlation, for example, calculate the correlation coefficients. In this case, COR is to calculate the correlation coefficients of the two vectors of numbers. We can also calculate the covariance, okay, of the two vectors. We might also want to combine the two vectors. So here we can use two commands. One is called cbind. It means to bind the two vectors by a column. So here, if we use cbind xy, we can just say x is here, y is here, right? And then it's column-wise binding x and y. If we want to do another dimension, for example, to combine these two lists of numbers row-wise, then we use this command called rbind. So to bind the two lists of numbers by the row. The first row is x, and then the second row is y. This is also helpful. You can imagine in some cases, usually we use this one. This is very common. So in some cases, x, it doesn't have to be one column. X itself can be a matrix like this, for instance. Each row is some data from some trial, for example. So subject number 1, 1, 1, 1, 1, trial 1, 2, 3 until 100, and some twice experiment, for example, twice 1, twice 2, twice 1, twice 2, twice 2, another column, and then reaction time, a few milliseconds, for instance. And then let's assume you also recorded their IQ score, but you recorded its IQ score in an external file. And then you will just have the IQ score for that person. And then, right? And then what you want to do is to concatenate or combine this IQ score to this existing matrix. And then this can be an entire data file or data set that you can work with. Some other very basic commands is, I list them here, but I will show you now immediately in R, okay? So the idea is that if you recall how the folders are structured from the GitHub, so here, we have all those folders, and we are now in the first one, 01.rbasics. And then there are a few folders, and here another shortcut that is new to us. I know you know that already, but this is like, we haven't talked about that yet in this lecture. So this is a R project shortcut. So what we can do now is to open that one. Yes, and we see a few information. Here, this is our version. And here, nothing here, files. This is the file, those are the files. Go one level up. Yeah, so here, this is the folder, the same as what I've seen here. So the idea of using the R project, I recommend all of you to use this R project shortcut. The idea is that whenever we want to do some data analysis, we want to change the working directory. And to change the working directory, we can do two ways. One is to go session in RStudio and then go down, set working directory, and then here, choose directory. And then the same as how you download a file, for example, you choose the location where you want to specify the working directory. And the second way to specify your working directory is to use the command, is to say set wd, okay? So to set your working directory. And maybe this is not something very ideal because you do not want to always manually set your working directory. You want something to be optimized. And what you can do is to use this R project. So the idea is basically whenever you create an R project shortcut, for example, in this folder, and then the working directory will already be inside this folder. So this is very handy. You might have multiple experiments for your master or for your PhD, for your whatever projects. So I recommend use separate R project shortcuts in each of the project folders you have. So then you do not have these directory issues anymore. Good. And then what we do now is we could go into this scripts folder. So there are two. So one is this R basics. The other one is R basics master. So throughout the entire seminar, we will get to see the structure, the same structure of the folder structure, same structure here. And we will see scripts like this very often. And it's always, there is one R script with this underscore master, and there is another one without this underscore master. So with this master means the exercise has solutions. So you can look it up later when you are doing that at home. So during the class, we work with this one, okay, without the solution, so that we can think, we can try to type, for instance. So now we just go here without the solution, without the master. Okay, go to the very top. So here, this is the one I showed you already. R version, you know your R version here. There are two ways to run commands in the editor. One way is to click this run button. And it also tells you there's another option to say Control plus Enter. So what I did is here I select and I type on my keyboard Control plus Enter, and then I will execute this command. And there is a similar command. You can also get your information. So here your R version and then some attached packages, for example, by default. So here below, those are the few commands that I showed you on the slides. I will just quickly go through all of them. Get working directory. Get WD means to tell me. So I will let R to tell me where am I in the current place. So this is the current working directory, the current place regarding where I am. So set is to change. So whenever you want to change your working directory, you have to type. Right, you have to type where you want to be. So for example, C, if this is a Windows, C is something like documents, something like scripts. Yeah, I don't have this folder, but just for example, if you do have this path, you can change your directory this way. Another one is called dir. Dir basically returns you the folder structure under your current working directory. So your current working directory is this command, dir directory. The output is the same as those folder structures, those files. Okay, good. ls is to list currently what is available in the environment. So you see here in the environment, I have a function called q, and then ls returns that to me. So this q is not a very good example. So what I can do now is to remove, for instance. So here, if you want to clear every variable in this working directory, there are two ways. One is to use this, the brush, but usually I don't use that. I use a command. I use this to clear everything. So if you see here, this is empty, nothing is there. And what we can do is now is to say, well, I just type 5. Okay, this because this doesn't write any variable into the environment here. This is still empty. What we do now instead is to say, well, we could assign a 5 to a variable called A. You see immediately the variable, there is something appears here, A and 5. And now if I do ls, so it tells me this, there is a variable called A. So ls basically returns anything here in your current working directory. Good. And the next command is the classic print, the printing function. So print hello world, and you use this quotes, double or single, doesn't matter, right? In this case, a single, hello world. And if you change it, for instance, to be double, is also the same output. Another one here is called cats. Cat is to concatenate. So here, if you pay close attention to how I call this command, cat is the function name. So here, there's a first piece of strings or characters. There's a second piece of that, and then there is a comma separating it. I want to concatenate the two pieces. So I can also say, well, hello world from Vienna, for example. I make it more complicated. So if you could see, right, there are 4 pieces of strings, characters, letters. Hello is 1, this is the second word, and from the 3rd, and Vienna the 4th. And if you type enter, and then the output is basically to concatenate, to combine all of the pieces of characters into a single line. Here, there is something called paste. This is also very useful. So when you have a project folder, you have your study. And let's say you have 1 folder per participant. And for example, the structure is C, study, subject 1, something like this, for instance. And some subject 2, subject 3, right? And then this is the structure. And you want to go inside into your folder to get the data, for example, data.txt file. Let's assume this is like an arbitrary example. So this is the structure. What is common is here, this is common. The disk, right? And also the study folder, this is also common. This is also, let's assume this is also the same across all the participants. What is changing is only this one. It changes according to which person that is currently. So we want to construct a folder string where only this one changes. So the way to do this is to use the command called paste here, paste 0. So what we can do is to do, well, this now we are in this folder. We can say study1, study, the study, subject1, right? Not good. It is because we need a slash. Yeah, looks good. So here we are in the C drive and the study folder, subject number 1 and data.txt file. And then if you want to change to the second participant, you only have to change this place from the first person to the second person. So this is one way to do it. There are some other ways, and I can tell you later in our exercise. Maybe not today, but maybe next month, I think. This question marker is to get your helping document. So for example, if I have no idea how to use the function called min, right? We can place a question marker in front of the min function, and then we press the enter button on the keyboard. We will then see here help and how to use it. The most important part for me, at least, is to go to the very end. So there are most of the cases a section called example. So here the nice thing is that because I told you we can use Control Enter to run commands, here the same idea. So if I select, let me do again. If I select those few lines, and on my keyboard I press Control Enter, and then those lines will be executed. This is very helpful. So you will see how those examples make sense. You will see how to use it properly. So in this case, basically, to assign a few numbers to a variable called x, and xm is to calculate the average of x, and then there's also a trimming. So how to use the trimming is also explained in this helping document. Good. There is a question I saw on the chat. Can we also concatenate without space? Yeah, we can do this one, right? Paste 0, there's no space. Yeah, okay, cool. Other questions? But let me still show you this. So paste 0, there are no space, but paste, there is a space. So paste 0 basically means no space. Space is one type of separator. We can also separate by anything, for example, semicolon. So then in this case, a semicolon is used to separate those elements. So paste 0 is basically a special case of paste. You can also imagine that if we say, well, separator is nothing, and then paste with this special separator will become paste 0. So this is basically a shortcut from R that makes it handy for people to use. Yeah, okay, there's another question. It says, what is the difference between cat and paste? Very good question. So what you can see here, let's use the same word, okay? Let's use paste 0 because paste 0 is just a special case of paste. So we can use paste, for example. What I said, let's use paste, okay? Paste. Let's use 3 elements. Hello world. Doesn't matter, Vienna, good. Those are concatenated with a space. We can do cats. It appears similar. You can already see a difference. Here there's the double quotes and also a one here, but there's nothing here. So what I can tell you is that if you assign these results from a paste to a variable called a, and a is basically this concatenated string, right? If we do the same thing for cat, let's say b equals the cat results, well then b is nothing. So the output from cat cannot be assigned to another variable. So that's the difference, the very important difference between the two. So the idea from us practically is that if we just want something to be printed here, maybe it doesn't matter. Maybe use cat because it looks cleaner without this quotes and also this. If we want to have the variable the concatenated result saved somewhere after the concatenating, we will then have to use paste, illustrated here. Okay, make sense? Other questions? 1 minute. Good. And then this one I talked about already. This one is to remove everything in this environment. And then if I run this will be cleaned. So here, to exit R, there are multiple ways, honestly. The easiest one is to click this one, the cross. This is the easiest. And we can also use a function called Q for quitting. If you say this, it will ask you also, do I want to save unsaved the changes? If I say save, it will be saved. If I say don't save, it will quit anyway without saving. Good. But basically just use this, the cross is fine. The quit command here, it is helpful only when you are doing your analysis on a cluster, for example, on a server. Usually Linux-based server. I can quickly show you. Okay, good. So this is the interface of a Linux-based computing cluster with a lot of memory, with a lot of calculating power, whatever. And if I want to use R, there's no R interface. What I can do is I type R here, and then this interface you see here, it will become an R. There's no GUI. There is no something you can interact with. There's only this terminal. Doesn't look very nice, but it's helpful, okay? If I want to quit R, what I can do, there's no cross button I can press. So then I have to use this quit command to, let's say, well, I have to quit. Do I want to save? No. So thank you, bye. So this is how to use R on a server. Very simple. So let me do it again. If you have any access to the server, any kind of server, type R, then the terminal becomes an R. What you can do is the same as what you do outside the server, the same as in your RStudio. You can say 1 plus 1 is 2, of course, A equals 3, and then A is 3, the same as what we have done regularly in R. Only the quitting, right? You have to type to quit. Perfect. Let me go back to slides. We have covered all of this, and help is to use the question marker, and also Google is very helpful to assign a variable. There are these 2 signs. We can just say there's no difference here, okay? You can use either this one or this one. Before I used this one very often, but now I changed just completely. I use the equal sign to make it easier. 2 other helpful commands. One is called head, the other one is called tail. So for example, if D is a variable that contains 100 elements, head will return the first 6 elements, tail will return the very last 6 elements. And another one is also very important, it's called save. So whenever you do some data analysis, you get some results, very nice results, exciting, and then you want to save it, right? You do not want to close R and then go home and then it's gone. You want to save it. To save it, use the command called save So here you give the variable name, and then here you give where you want to save it. Here, the only place to pay attention to is that the R data type in R is called .R data. Let's say you save your results, and then you go home, and then the next morning you come back, you want to work, continue working on that. You want to then load that result, and then to continue work on that, right? The idea then is to load the data you have. So here the function is load. You only give one input argument, which is the path of the data. So here, this one is the same as this one. Again, pay attention to this data file extension, R data. Here is to clear everything in the current working directory, the workspace, the memory, and then Q is to quit, to exit R, as I said already. So RStudio is an editor, as I said, and there are a few other quite useful commands. So here, Control-L is to clean the console. Control-Shift+N is to create a new script. Use the up arrow sign on your keyboard to look for the command history, and then to hold the control button, and then type the up arrow button, then you will see the command history starting with a certain letter. I will tell you what that is. And the Control-Enter is the one we have talked about. You select the lines in the script, and then you run it by pressing Control and button. Control and Enter. The example I can give you now is, so I've done this quite a few times. So A is 1, 1, 2, 3, 4, 5, blah, blah. So here you see this is quite busy, right? This is quite busy here. And you want to have a clean start. What you do is you say, well, Control-L, and then this is cleaned. So here this is cleaned. But here, nothing is changed. It only clears the space, but it doesn't remove all those variables. Now I'm pressing the up arrow because I just randomly typed a few things. So this is command history, right? The command history. Good. This command history is not very helpful because it's the entire history. If you want to look for some specific commands you have typed, for example, from 2 days ago, and you have to go to thousands of commands, for example, if you type a lot. This is not ideal. So what you do is that if you recall how did you start your command, for example, I run the model. The model is called fit, F-I-T, and then I want to see how I used my command. So the way to search for a command history that starts with the 3 letters fit is to hold the control button, and at the same time press up arrow, and then you will see everything in your command history that has started with the 3 letters FIT. And then, for example, if I'm interested in a LMER model, whatever that model is, so then I can reuse the line. For instance, I want to keep the same formula, and then I just change how the data is constructed. So I used the command to do one data analysis. I want to change the data set. I only have to change here, for example, from Q to P. Yeah, as my example. So this is very handy. So again, if you remember how the command is started, type it, hold the control button, and then at the same time press the up arrow. This is very helpful. What else on the slides? Yeah, Control-Shift-N, well. So here at the top, this is the editor. If we want to have a new one, well, Control-Shift-N. and then a new one will be created. The same as if you go to File and then New File, R scripts, right? The same. But I usually prefer to use shortcuts. Up to you. Good. Let's go back. Some Windows system general shortcuts, the same as if you write your thesis, write your paper, write your whatever. So those shortcuts are the same. So if you hold the control and then plus the home button or pause signs, so then it will go to the very top of the script. Because, for example, at the very top, you want to write some comments, right? And the same is to do here. If you hold the control button and then press end or enter, and then this will go to the very bottom of your script because you want to expand your script, for example. You want to expand only from the bottom, not from the middle. There's some other tool. So here is to hold the shift button on your keyboard and then press up or down, and then lines will be selected. Here, if you hold the control button and at the same time, if you press left or right, words by words will be selected. Words means anything separated by a space. I can also quickly show you that. I'm in a script somewhere in the middle, and then here my cursor is here right now, here, and then I'm now pressing the shift button and then press up and down. In this case, down. Those lines, line by line, will be selected. So again, my cursor is here, and now I am pressing the control button instead of the shift. You see, like word by word, right? Separating by some separator. Can be a comma, can also be a space, can be like a anything, yeah. Very helpful when you are editing your thesis, for example, and here when you're editing your commands, editing your script, it's very helpful. Any questions so far? Have a second break, water break, stretch yourself. No? Good? The next small topic is about data class. We have seen letters, A, B, C, hello world, phrases. We have also seen numbers, 2, 3, 5, for example. So what are data types? These are numeric with the floating points, decimal points, and integers, 1, 2, 3, right? Characters or string, this is just letters, hello world. It is specified within the double or single quotation marker. Logical variables in R or in other programming languages, true or false. Factors, this is important in R. So we code categorical variables as a factor in R. For example, male, female. For example, placebo group versus control. For example, drug versus control. For example, patients versus healthy. Any just categorical variables. And also complex number. So it doesn't matter, we don't have to talk about that. And we do not work with only one-dimensional data. We do not work with one number. We do not work with one letter. We work with a list of numbers. We work with a matrix, for example, a data frame. So what are those data types in R? So there are quite a few. In this case, 5. That's quite complete, I think. So vector is here either one row or one column vector. Dimension is 1. Matrix is like this, like a table. There are 2 dimensions. One is the number of rows. The other one is the number of columns. In this case, it is a 4-row by 3-column matrix. There's something called array. Array can be super complicated, complex. In this case, it is a 3-dimensional array, 3 by 3 by 3. This one, data frame, it appears to be the same as a matrix, also 2D, 4 rows by 3 columns. I'll tell you later what the differences are. And then the last one is a list. It's like a container. It contains everything can be put into a list. We can put vector into a list. We can put array into a list. We can put data frame into a list. We can put another list into the list. So list is basically as a container. The difference between data frame and matrix is that in matrix, all of the data, they have to be the same type. For example, here is 1, 2, 3, 4. Here, it has to be number as well, those columns. Here, the same. And then in data frame instead, each column, the data type can be different. So for example, the first column is number, so subject number, for example. The second column is the factor, the categorical variable we mentioned. So it can be male, female, male, female. You see the data type is not a number, right? It's different from the first column. And then the third column can be a string, for example, can be their names within a double quotation marker. So it's also another different type. So this is the main difference. Both of them, matrix and data frame, they are 2D. Difference is that here, all the elements in the cells, here each cell, they have to be the same data type. Everything has to be number, everything has to be character. Here, it doesn't have this constraint. So each column, they can be different. Not each row, no, each row, no. Also doesn't make sense. So each column, it can be different. Number, factor, character, logical variable, for example. So all doesn't matter. So this is the most powerful data type in R. So for example, if we read in a text file from the folder into R, it will automatically be constructed as a data frame. And nearly every analysis we do, we deal with data frame. So this is very handy. And if you know Python, and then if you know a library called Tanda, something quite similar to this one. Good. Small exercise. So I will show you. So the way to do the exercise can be a little bit challenging. So what I have in mind is that I select those few lines that you are supposed to work on, and then you think about that for maybe 5 seconds, and then I will run it and I will explain it. And then later on, you can also do it at home to practice it yourself a little bit more. Good. The purpose of this exercise is to experience different data type. So there are 2 commands very helpful. So one is called class, the other one is called structure. So here, for example, if I say assign 5 to A1, and then I change or convert the type of A1 to be integer, and then assign that to A2, and if we class it, if we want to know the class of A1 and also the class of A2, so what that can be, so what's the results? You can think about that for 2 seconds, enough. So if we assign 5 to A1, the class of A1 is not so surprising, numeric. And then if we want to convert A1 to be integer, and then not surprisingly, the class of A2 is an integer, right? So B1, B2, both hello worlds. Difference is here, use a single quote. Here, use a double quote. And then we do the class. Shouldn't be surprising. Both of them, they are characters here and here. Those are logical variables. You run them, and then class, oops. Class is logical. So capital T, either capital T or the full spell, or capital letter true, they are logical true. Capital F or capital false, full spell, they mean, both of them, they mean a logical false. So usually I recommend type this full spell instead of using the single letter. Okay, here the next class, next data type is factor. We assign letters, so I explained this a little bit. The letters in R, it is a special variable. It basically contains letters from A to Z. And here is indexing. I haven't talked about that, but just stay with me. Indexing here, I want to have the first element of letters twice, and then the second letter in letter also twice, and then later the third to the 10th of letters. Okay, good. If I run it, we will see, okay, A twice, B twice here, and then from C to J, okay, whatever. So what I can do now is that I can run class. Letters by default, those are letters, characters. And if I want to convert those letters to be factors, to be categorical variables. So what we see is that F is now a factor. So now what is F? Okay, F is again the same sequence as here, but there are levels. So even though A appears twice, they are the same level, just A. So even though B appears twice, there's only one level called B. So another example I can give you is for instance, we have 10 participants. Here, male, male, female, female, male, female, until the very end. The levels will be only 2 possibilities, either male or female. So this is a much easier example to understand, I think. Yeah, so here, good question. The question is, if I use index from 3 to 10, does that always include both the starting and the end? So to answer this question, basically I have to tell you the index starts from 1, not 0. If I have a vector, A means 1 to 10, so A1 is 1, right? So the starting is 1, 0, no. So the index in R starts from 1, not 0. So then in this case, if we say 1 to 10, it basically means the first to the 10th, including both the beginning and the end. Here vector v1, 1 to 12, v2 some other numbers, v3 some repetition. So here to repeat. Here means to repeat double A 4 times. So if we see the results, okay, V1 is, did I? Okay, smaller case, I made a mistake. So V1, 1 to 12, V2, some numbers I gave, V3, those numbers, right, letters. And then if I say class, V1, integer, V2, numeric, V3, character. So you see there's an interesting difference. The class, the data type of V1 is integer, and here V2 is numeric. Why is that? It is because if we specify consecutive numbers in this way by using the semicolon, the colon, and then we will get integers here in this case. Even though here those are also integers by the definition because there's a colon, those are not. Those are like by default numeric numbers. And then if this is a mixed data type, the entire thing will become numeric with the floating point data type. So just some little things to pay attention to. Usually it doesn't matter. You do not have to worry about that. Good. So now since we have the V1, V2, V3, all of them, they have 12 elements. So how can I know how many elements there are? There is a function called length. V1 12, V2 also 12, V3 also 12. And what we can do, for example, is to, well, I think I went too fast. Maybe I can go here. So we can just combine them, right? We can combine the 3 variables into, for instance, a data frame. So recall that we also have a variable called f. F is these letters. We can combine them. So this is to demonstrate the data frame. Each column, they can have their own data type. So to construct a data frame, we use the function called data frame, and then we do this. And then we call it df, class of df. Not surprisingly, it is a data frame. Whenever it is a data frame, we could use another helpful function called str for structure. So here, we know the structure of the data frame. So what is structure? The structure is that the mother, the core is a data frame. There are some children. And then the first one is a list of integers. The second one is a list of numeric numbers. The third is a list of letters, characters. The fourth, it is a list of factors, categorical variables. So you see here, each column, they can have their different data type. So if you type the df, you will see the entire 2D table-like output. So if I can show you this, because I didn't show you, head, it returns the first 6 elements. And then if I say tail, it returns the last 6 elements from the 6th to the last and also to the last. Okay? Good. What is also helpful is here, if I want to, we have the data frame, but now for some reason I only want to work with the first column. So how to do it? It is to use the dollar sign. The dollar sign is like to assign the subfield of the data frame. So then we have the first element. So pay attention to here. Each element, each row of the data frame is not a data frame anymore. It is whatever they are, right? So here, if I say the data type of the first column of the data frame, it was an integer, it will be again an integer. So the same, it shouldn't be changed here. And then now I can go here to show you the matrix data type. So recall that we have a list of integers from 1 to 12. And now I want to have a matrix, a 3-row by 4-column matrix. So what I can do is to convert those numbers into a matrix. So here I will have a matrix like this. And let me just run this first. I have another matrix. So let's see a difference. We have numbers from 1 to 12. So how those 12 elements will be ordered if I want to convert this vector into a matrix. By default, it's column-wise. So 1, 2, 3, 4, 5, 6, and then from 7 to 12, column-wise. It goes vertically. And if instead I do not want this way, I want them to be like this, row-wise, horizontally. So how to do it? So we have to say by row true. So R, it is a column-wise language, MATLAB as well, Python I think also, not sure. So if we do not say anything specifically, explicitly, then the element will be listed column-wise, okay? Otherwise, if we tell explicitly by row, then this converting from vector to matrix will then be run by row horizontally. Good. To make it more complicated, we can also convert this V1 vector into a three-dimensional array 2 by 2 by 3. Don't have to show you that, but basically, well, haven't run this. Yeah, so the class of M1 is a matrix. Class of the array, the ARR, is an array. Questions? Everything's all right? Good. Now I continue. There are quite a few logical operators, like smaller than, greater than, smaller or equal to, greater or equal to, equal or not equal. But here, double equal sign means equal, and here this one means not equal. And in general term is like, if x is something, and then this means not x, the opposite of x. And we have the logical or and also the logical and to combine conditions, for instance. The results by using those logical variables, logical operators, will just be logical variables. Not so surprisingly, what we can see is that if we compare if 0 is smaller than 1, it is true. If 0 is smaller than -1, it is a false, okay? So those results, by using the logical operators, will just be logical variables. And when we know this, we will use those logical operators to construct control flow, for instance, to do if-else, and also to do some for loop, to do loop. And if-else is, the if-else statement is very important. It runs your commands by condition. So here it means if this condition is true, then go ahead and run. And if this condition is not true, then those statements will be skipped. This is the if-else statement. It can be a little bit more complex. So if this condition is true, run this. Otherwise, run this. So those conditions also doesn't have to be two or twice. It can be multiple. So if this condition is true, run this. And if this is not true, however, this is true, then run this. And if all of the above conditions are not true, then run this. So this is conditional operation. So one example can be that if the reaction time is smaller than 300 milliseconds, do something, and then else means the reaction time is not smaller than 300 milliseconds, meaning larger than 300 milliseconds, then do something else, okay? Here can be if the reaction time is smaller than 300 milliseconds, do something, and if here the reaction time is larger than 5,000 milliseconds, like do this, and then here this else basically means the reaction time will be within the range in between 300 milliseconds and 5,000 milliseconds, and then do some analysis, for example. Here, the loop. So if you are repetitively doing something, you're repeating yourself, maybe it is one place to run the loop. So for example, we have experiments, we have 100 participants, and we do the data analysis for the first person. And then we want to do the same data analysis for the second person. We do not have to write the commands repeatedly for 100 times. We just run one time because there is a common structure, and then we change the subject index. So here's the idea. So for subjects in, for example, from 1 to 100, do the analysis. So when the analysis for the first person is done, it's finished, then it goes to the next. Second person finish the analysis and then go to the third and then fourth and then until the 100 participants. Then your analysis is finished. For loops can be nested. So here there is a for loop inside another outer for loop. So for instance, when we want to do some analysis, not at the subject level, we want to do analysis at the trial level. So here, the outer loop can be participants, the inner loop can be trial. So for participants number 1 to 100, and then for each trial from the first one to trial maybe number 80, and then do the analysis per person, per trial. And then this loop runs over and over. It will be finished when every participant, every trial is processed. There's a question, is there also elif in Python or always else if? Yes, always else if. You always have to write this way. You always have to write the curly brackets. There's no indentation, there's no colon. So this is different. But you will see it from the exercise. Well, I mean, the indentation is not obligatory in R, but I still do it because the code, the command will look cleaner. It's more human readable, right? So let's talk about functions. I used this term already. So when we were talking about, for example, the sum to calculate the summary, and then the mean to calculate the average, those are already functions. So what are functions? So functions are basically the operation or operations, multiple, to obtain some quantity based on another quantity. Using this one is more clear, I guess, clearer. So there's a function like black box to give some inputs called x, and then we will obtain some output fx. So with the x as input, we get something as an output. So the input here can be a list of numbers. The function is the mean called mean. The output here is the numeric arithmetic average of those list numbers x. If we use sum, the output will be the summary. If we use var, and then what we will get is the variance, and so on and so forth. Functions, there are different, let's say, sources. If you install R, there are already quite a few built-in functions, like min and sum. They are just the basic min, sum built-in functions in R. And if at some point those built-in functions are not enough. You want to do something a little bit more complicated. And luckily, if somebody else outside, they have already written some functions to do this specific type of analysis. So those are like packages. You download the package, then you can use it. But the package is nothing, just some functions written by somebody else, and then you can use. Some other cases can be that both the built-in functions and external functions from the packages are not enough. You want to do some really a specific type of analysis. Nobody has ever done that before. So what you can do here is, well, you can write your own function. So here, that's the last one, user-defined function. The syntax of user-defined function is like this. Here, there is a reserved keyword called function. Here, in this parentheses, we give the input arguments. And inside the curly bracket, that's the body. That's how you want to deal with the input arguments. And then do something, do analysis, for instance, and then return the output. And then the function name is called function name. And it is at the left-hand side of the equal sign. So recall the general idea. The equal sign is always we are trying to assign something from the right to the left. It can be a equals 5, means assign 5 to a. Here is just a little bit complex. We assign a function instead of a number to a variable, and then this variable will be a class of function. If we say class, recall the command class, in the parentheses we say fun name, it will be a function. It is a special type of data, or object if you prefer. One example. We are most of the time interested in the standard error of the mean, but there is no function called the standard error of the mean in R. And we can use some package which has the standard error of the mean, but maybe we can just simply write our own because this is a simple function, only one line. Standard error of the mean, by definition, it is the square roots of the variance and then divided by the total number of elements minus 1. So we just basically implement this function in R. It's like we are translating this equation into R language. So we give a function name, SEM, equals function, inputs a list of numbers, let's say x, it is a vector, and then we write the curly brackets. SQRT means square roots. VAR means the variance here, the variance of x, divided by the total number of x, length, minus 1, okay? So there are two things I didn't say. So one is here to remove the NA. If, for example, there are nuns in this x, this NA, this missing value, will not be used to calculate the SEM. So then the NA will be removed. And here we also have to do the NA remove. And then here it's basically another way to remove the NA. So basically to show you how you can do it, how you can use it. And then when this function is written in R, we can make it available to R, and then we can use it. I will show you during our exercise. Okay, it's already the exercise time. Yeah, good. So let me go to R. Copy paste. I don't want to change the file. So there are two analysis to exercise here. One is the if-else statement exercise. The other one is the for loop exercise. So the if-else exercise, the idea is like, First, to generate a random number between 0 and 1, and then compare it against 1/3 and 2/3, print the specific random number and its position relative to 1/3 and 2/3. By example, so here, the first line is to randomly generate a number between 0 and 1. And then example output is like this. This random number is 0.895, and then it is larger than 2/3. So this is the relation relative to the threshold, the cutoff. The next exercise is about for loop. So get the name of each month, then just print it one by one. Okay, and then to use for loop. The expected outcome will be like this. This month, January, February, March, April, May, and until December. So this is exercise. So what we can do is to, let's look at here. So all of you, maybe 10 seconds, think about it. Okay, I guess you have more or less some idea. The first line is simply to randomly generate a number. Okay. If I do this, if I do not do the assign, I just say RUnif1, it will give me a random number each time. You see, very different, just random numbers, but always in between 0 and 1. We can talk about the random number generation later, we will. The idea is basically here, we randomly, here R, randomly get a number, one number here from a uniform distribution. And by default, this uniform distribution is from 0 and 1, okay? Whatever that is, T is now a random number between 0 and 1, and we want to compare that against two thresholds. One is 2/3, one is 1/3, the other one is 2/3. So here we use the cat command to print the results. What the value of T is, and then how large it is relative to the two thresholds, two cutoffs. So if we look at here, there are already some hints. So the hints is that we can just run this line. Whatever T is, I can get rid of if else. I can either we are the people, we are the person who is coding this. Why not just go inside and then to test, right? We do not have to go through the if else because it's incomplete. Well, we just run it. So cat is to concatenate. T is T. And then in this case, it's larger than 2/3. I don't care this result if that's true or not because I haven't run that. I just want to see what the output is of the cat command. I can also run this, it runs. I can also do this, no, not running. But then you can see here, there's error, something is missing. You basically look here. T is something is missing. So the T number is missing. You basically give a T here. And then this line can be run, okay? The next place, what is missing is this condition. So if T is smaller than 1/3, go here. And if something is happening here, it runs this line. So the hint is here, right? It tells you, well, I want to print T is larger than 2/3. You need to tell me what the condition is. The condition is simply T is larger than 2/3. And then the remaining, the else, the remaining is larger than 1/3 and smaller or equal to 2/3. and then this chunk is complete. So what I can do now is select those multiple lines and then Control Enter, right? The idea, the same idea. And then you see here, that's the results. So it is 0.38, and it is in between the two cutoff. I do this again. You just pay attention to, I will run here. You can just pay attention to here what the outcome is. I run again, it's 0.06, smaller than 1/3. I run again, it is 0.25, smaller than 1/3. In this case, 0.66, in between the two cutoff. Again, so 0.72, larger than 2/3. So it basically runs, okay? This makes sense, I guess. Test if else. Questions? Yes. Yeah, go ahead. You can also speak if you want.
Hi, can you hear me?
Yes.
I was wondering, is there also a way to suppress the output of the lines that we scripted in the console? Like in MATLAB, you can do the semicolon and it will suppress the printing of the line that we coded and just give us the result.
Yes, so if you say here, t is 3, it is already suppressed. Suppressed, right? It's like this in MATLAB, and we do not see the result printed in the console. Is that the question?
Yeah, but when you execute the code from the script on top, then it will print in orange letters the script again in the console.
You mean this part?
Yeah.
I don't know. I don't know. I'm not sure.
Okay, so basically it means that when we run a script, we will also always see it in the console, like running all the lines.
Yeah. I show you my example. So what I can do here is I first comment it. I think I never talk about comments. Comment is to use the hashtag. So now this entire script only contains the if-else part, okay? So what I can do now is to save it. I save it as, just here. I will delete it later. Test if-else .r, okay, good. I cannot even close it. So what I do now is to source. I run it. I want to run the script. Yeah. So now here you don't see the other stuff. You only see the results. So if you run this, whatever multiple times, you will see the t value and also how it is larger or smaller than the 2 cutoff. Does that make sense? Is that what you want?
Yeah, thank you.
Yeah, okay, cool. Thank you. Oops. There we are. Yeah, we are here. Okay, good. And then if you know LaTeX, this \n means to have a new line. To press the Enter button on the keyboard, it is equivalence. And another handy thing, for instance, if you do not want to see so many numbers, digits after the decimal, let's say we only want to see 2, right? And then we know 1/3 how large that is. We know how large 2/3 is. We just want to see 2 digits after decimal, or maybe 3. Let's say 3. So what we do is to say round. We round it, and then we want to retain 3 elements, 3 digits after decimal. Lazy, I'm just copy paste. But always pay attention to copy paste. because that might go wrong quite easily. Now I can use the source command again, right? Because now I rounded everything. So the results, we see the t variable only contains 3 digits after the decimal. Perfect. Good. The next exercise is about the for loop. The very first step is to get the month name. Now, 2020, we do this. So here it is to use some built-in R data type here, or R function, to get the formula like appears like a data, like appears like a month name. So basically, to get a list of month name. Okay, this is trivial. Don't want to explain this. And what is important is to write a for loop to print the month name line by line. And the expected outputs, as you recall from the slides, is like this. The month, this month is January, the month is February, the month is March. Okay, good. There's a for loop. The J is the iterator. So the J changes from 1 to the length of month name, because we have 12 months. So then the J changes from 1 to 12. 1, 2, 3, 4. What is missing is here, okay? What is missing is the cat command. I give you just 5 seconds to think about it. So the structure is this month is, and then how we use the month name and how we use the J. We have to use the index. So how we use this to print each line as the expected outcome. So what you can do now is to do this a little bit slowly, like incrementally. We know the variable month, we know there are 12, and then we can run it. It's no harm. We can just print this month is 12 times, right? Doesn't make sense. And we see here, they are just connected because we didn't press enter, like virtually. We didn't press enter to make a new line. But I told you already how to make a new line here. Use this \n. Do it here first. And then here, again, do this incrementally. Well, now every line is a line. Every line is a new line. What is still missing is the month name, right? So the month name, we can do some test. We could do some test. So the for loop, if at the very beginning, if that is in any way a little bit complex, then you just do a little bit experiments. So we have the month name. We can do the index, right? Index is to use here the square bracket. 1 is the first month name. 2 is the second month name. 3 is the third month name. 4 is the fourth month name. We know this. We know how index work. For example, if J, we can just manually assign a J to some, manually assign a number to J. We can just say J is 1. And then what is changing is J, okay? J is now first. We can combine these two lines. For example, J is 1. And then month name J, the Jth month. 2, 3, okay? So this is the changing part. And then we want to use this idea into the loop. So this is the testing part. If you write your script, write your code, you don't really do this in your script. You test it in the console, and then you implement your idea in the script in the upper part. So what we do here is we want to have the month name the jth. Okay, good. And because we concatenate it, we then have to put this one a little bit further away. So now, if we run this line, yeah. So then we have the month name. So this month is January, this month is February, and there is a space not necessary. So yeah, okay, this looks nicer. I don't know how to get rid of the last space, maybe without the period. Yeah, okay, this looks nicer. Questions? So the general idea of the for loop is we have iterator. We loop it from the first one to the last. In this case, as many number as the number of month, 12. Here we use this changing variable j because this one changes. We want the first element of month name. We want the second element of the month name. So this is the changing part. We use j as index, and then we concatenate it. Let's say sentence to combine what we want to implement. Questions? Yes. There is a suggestion to say, can I use backslash to escape space? I guess maybe yes. That's a good idea. No, maybe not. Not sure. Double. No, I don't know. I need a space, right? Yeah, I need this. Yeah. Okay, should be. No, sorry. Another question, can I assign any letter as the iterator? Yes. So this can be anything. It can be n here. You see the change? This is now n, this is n, as long as they're the same. So here, iterator doesn't have to be one letter. It can be something more informative. For instance, it's a little bit stupid, but we can say this is number of subject, okay? Number of participants. And then this n subject can also be used as an iterator without any problem. So we run this can still be run. So iterator is arbitrary, whatever you like. You can use any letter, any phrase, any variable name. Any questions? Other questions? So let me just quickly finish the built-in function exercise, and then we can have the break. I almost forgot the break. So the exercise here, we can do it here. So we know there is already a mean function to calculate the average. So we want to have our own mean function to calculate the average, and then to experience how mean is calculated, how a function is constructed. So I can just write a new one. I want the function to be called as my_mean, and I know the keyword called function. The input is x, a list of numbers, and then curly brackets. I'm doing this is basically because I want to show you how I usually code or write function. I first write the structure, the skeleton, nothing in between, right? I just write it with the input, with the curly brackets, okay? Nothing else. And then I write what I want to do. So with the x, how the mean is calculated? Well, it is calculated by using the sum divided by the number of elements, right? This is the definition of mean. Okay, we could have a variable called x bar, means the mean of x. It is the sum divided by the length length of x. Good. And maybe assuming there are some missing values, we could also handle that by using NA remove. It's true, we remove it. And now I can tell you why I didn't use NA remove in the length calculation on the slides, because NA remove does not exist for this length function. So then what I do is to say, well, NA omit x. This is to remove the missings of x first, and then calculate the length with the already missing removed variable of x, the remaining, the valid x. Okay, good. This is the function we wrote. So how to use it? To use it, we first look at the environment here. It's too busy. Well, let's first remove everything, clean it. Now it's cleaned. Here, TMP means to have 10 random numbers from a normal distribution, okay? Just 10 random numbers. Good. And I want to calculate the mean of 10 PNP variable using my function. It's not there. It tells me could not find the function my mean. So the idea is that writing that is not enough. You have to tell R, I wrote a function. I want you to use it. So the way to use it is to select those lines, the same as when we execute a few lines. Here we say Control Enter. And then what you see here from the environment tab, there is a data type. There is a variable called my function. The type is function. So what you can do a sanity check is to have ls recall to list all those variables currently in the working directory. We have a temp variable for the 10 numbers. We have a myMean function. If you type it, it tells you, this is a function. Perfect. And then if you recall our favorite class function to know the type of the data type per variable, not surprisingly, it is a function. Okay, good. So now we have told R there is a function, you can use it. It is available, it is loaded in the environment. Now we can use it. Perfect. I mean, okay. Nothing is returned. This is very interesting because one thing is missing. We haven't told R to return it. Good. So now, because we made a change, R doesn't know we have made a change. We have to do again to tell R explicitly we have made a change. We have made a change of the function. Use a new one. Yes. Now we have the mean calculated. So here, the last sanity check is to compare if the result from my mean calculation is the same as the default mean or average calculation. So to check if the outputs are the same, we use this function called all.equal. So we say it. Full, yes, so it shouldn't be different. So this is simply the summary divided by the total number of elements. We can make it a little bit more interesting. So PMP recall there are 10 numbers. We could manually say, well, the third one is a missing. And the knife is also missing. So now the temp variable, you see here, there is a missing NA, there's another one. Good. Because we have handled this situation in our function, we do it again. We calculate the average, this number. We want to know if that also gives us a reliable result relative to the built-in mean calculation. No, not. No, yeah, because this one, it doesn't. So yeah, we have to tell mean to do this. So our way is a little bit smarter, I guess. Yeah, now it's true. Good.